is reality? Who is reality? Why is reality? These are the questions we will not be looking at today, because today we'll be looking at
Bruh.
Virtualization. Okay. What? Okay, sweet, cool. So, how we're going to do this is we're going to split virtualization, the whole concept, into multiple videos. In this video, we will just look at the theory and a high-level explanation on what is actually happening, right? So we'll start with what is virtualization. So there's a definition on the screen right here, but to understand this, so what it basically is just saying is that it's using software to separate and allocate the hardware to operating systems. That's literally it. So we look at the next slide, which will show you like an image. So this is the image. So we have the hardware at the bottommost layer, right? It's literally raw. You can touch the physical hardware. You can go and touch your CPU if you want to. What in virtualization, there's two types, but the most easiest way to understand this is if we look at type 1, which is literally your hardware at the bottommost layer, and then just above your hardware is something called a hypervisor. Now what this does is, in the most simplest terms, is it manages the allocation of resources from your hardware to other operating systems that sit above it. So if we look at the diagram here, there's the hardware at the bottommost layer. Above that is the hypervisor. The hypervisor looks at the hardware and then says, oh, okay, so the red OS, which is red operating system in this case, will have 2 cores of CPU, 1 GB of RAM, and stuff like that. So the hypervisor is the middleman to allocate the operating system its resources. That's how it works in this specific example, right? And this is basically virtualization. So instead of having your hardware and then an operating system, you have your hardware and then a management software, or like just a management hypervisor, which looks at the hardware and then allocates the resources, like however you configure it to. And then the operating system at the topmost layer, which just thinks that, oh yeah, this is, I'm running on the hardware, so yeah, that this is how many cores I have or the hardware has and stuff like that. We'll look at an example later on, but the concept is hardware, management software or hypervisor, final virtualized operating system at the topmost, and that's literally it. That's the whole concept, right? Now, there are basically two types of virtualization. Yeah, two types of virtualization. One's at a hardware level and one's at a software level. So we look at type 1 first, because that's a bit more easier to understand. Type 1 hypervisors is literally virtualization at the bottommost layer. So we have our hardware just as before, and then we have a hypervisor, and then we have the operating system. That is the whole concept of type 1 hypervisors. So technically speaking, you're dividing your hardware into specific containment zones, and then each containment zone is like each operating system is allotted certain containment zone or parameters that they will then use. All of these operating systems here could be running simultaneously if your hardware allows it. If you have, like, let's say on your CPU you have like 50 cores or something like that, you can allocate like 2 cores each and then have like, I don't know, 125 machines or something like that running at the same time. It would be fine. As long as your hardware allows you to do it, you're good. It does not matter. And your hypervisor is basically that software that sits in the middle of your hardware and operating system and says, okay, cool, I will monitor each operating system and let them know how much resources they are allowed to pull from the hardware and use, right? Just so that it's contained within their sector, and that's just how it works. So now when we look at performance for type 1 hardware levels, like hardware level hypervisors, right? Or type 1 virtualizations, or whatever you want to call it. The operating system and the hardware is divided by one layer of abstraction. Let's call it abstraction, just because the hypervisor communicates to the operating system the configuration that you have given to say, hey, this is it. Oh, there we go. So this is it. This is how many cores you get, and that's it. That is the hardware. So the operating system at the end thinks that the hardware it's sitting on is the only hardware available, unless configured otherwise. So all these operating systems, the blue, red, whatever these colors are, I don't really know. But yeah, all of them think that they are using all the hardware that is provided to them, which is correct. But the hardware provided to them is not the total hardware present. So let's say, for example, you have a i7 hexa-core CPU, right? You could allocate like 2 machines. Let's say you give each machine 3 cores. So each operating system thinks 3 cores is all the machine has, but that's not really true, because the machine has 6, right? So then when you separate them, each machine thinks, oh, they're getting all of the resources allowed. Everything goes through the hypervisor to the hardware, and that's how it's all allocated to each of them, right? And that's the one layer of hardware abstraction that's between the operating system and the hardware, and that's it. So it's just the hypervisor, which is saying, oh, this is what's the hardware, use this. And now the use cases are, let's look at this, right? So type 1 hypervisors, why are they actually useful? Okay, so let's say you work in a company, right? In a company that has 3 different hardware pieces. So let's say 3 different computers that are performing 3 different like functions. So let's say computer 1 is like a mailing server, computer 2 is a web server, and computer 3 is a file transfer protocol, FTP server, right? So it has files, and you like take files and put files out, whatever, it doesn't matter. Now, because like let's say your organization is not using each of those devices to its full capacity. Let's say it's only using like 30% of the hardware hardware capacity, right? You're actually wasting 60% of the hardware, like resources available to you for each of those computers. So like if basic business is like you reduce your opportunity cost, right? Just so that you can like be more efficient or like effective or whatever. Yeah. So if you're wasting like 60% on each computer, 60% of like utilization, or is it like 180? 180% like lost, or CPU utilization that's just lost straight up. So that's not really good, right? So because you're losing a lot of like resources that you could be using elsewhere. So what you can do with virtualization is put all of them in one computer, so you can utilize the resources of one computer, have your hypervisor between the hardware and the operating systems that run the mailing server, the web server, and the like file transfer servers. What that does is that actually increases or reduces your opportunity cost, because you're then using 90% of the machine itself, because everything is abstracted, right? And all these machines, so the email server, the mailing server, the web server, and the file transfer server, running in different spaces within the computer, and like they're totally separate from each other, but they're using the same computer at an underlying level, right? And it's much more efficient, because you don't have to like manage 3 computers. You just manage one hypervisor and the hardware that it comes with. And this is the basic concept of virtualization, and this is type 1 virtualization. So you have hardware, your hypervisor, and then your operating systems or machines, right? And that's it. This is the beauty of it, because you can utilize more of your hardware in cases where you would need a dedicated machine, and you can have multiple dedicated machines on one machine. But those dedicated machines, those like operating systems, are all virtualized within their own compartments. So that's the beauty of it, right? Because you're taking hardware, dividing it up, and giving it to operating systems bit by bit based on how much they need. And they think that they're getting everything that's there, and they are completely separate from each other. But little do they know that they're all on one piece of hardware, and that's it. That's literally type 1 hypervisors, or type 1 hypervisors in virtualization. Now we'll go to type 2 hypervisors, right? Which is type 2 hypervisor, which is software based. So this, generally speaking, doesn't have any server large scale uses, because it's not very efficient. So what this type of hypervisors really are is basically you have your hardware, at the bottom. You have your laptop, you have your computer, whatever, it doesn't really matter. Then you have your host operating system, which is Windows, Linux, I don't know, don't care, whatever, Mac OS. You can have whatever you want. Now, above your operating systems, you have your like applications. So like your web browsers, your Spotify, like any exe or whatever you run, right? Your Chrome, your Microsoft Edge. You, alongside all of those, you have certain hypervisors that are like provided. Now, these hypervisors are software based, and above them is what you run your operating systems or individual machines, right? So basically, if we start from the whole process is your hardware, your host operating system, Windows or Linux or whatever, then your applications, along with your hypervisor. So your hypervisor is an application at this point. So we look at it later on, but like your hypervisor runs as an application on your host operating system. So if you have Windows or Linux or Mac OS, you will have a application based hypervisor, which will be like VirtualBox or something, where you double click it, it opens up, and then inside that application you're able to run virtual machines. Now, because there's so many middlemen that will abstract the hardware, that it's not very efficient. But like most PCs today, like personal computers, handle this with like no problem. It's like fine. Like they're just like it's easy because it just like it just goes through it with like no problem at all. So in performance though, like when you on a personal computer level, if you're running one virtual machine using this type of software-based hypervisor, it's fine. Does nothing. It'll be like it'll work fine. But let's say you're running multiple things, right? Like 4, 5, based on your hardware, it might start to have latency issues. And the only reason why is because if you can see here, because the operating system, the final operating system, or the virtualized machine, needs to access the resources of the hardware through. I mean, it needs to go through the hypervisor and then needs to go through your host operating system and then get to the hardware. So because there are two layers of hardware abstraction, this makes latency an issue. So you can't really do you can't really have high functioning workflows. I mean, you can, but it just might be a bit slower. That's about it. It's just a possibility of latency issues, and that's about it, right? Now we'll look at it's just a summary, kind of. So if we look at Type 1 hypervisors, it's just a bit more efficient. That's about it. And it's generally used, it's very good for scalability, right? Because the only, not con, but it's a, what do you call it? It will be something that comes with this type of virtualization or Type 1 hypervisors is you need an orchestrating computer. So you need a computer that sits back and just controls everyone within that space. So all the like a commander, think of it as a commander, right? So you need like a commanding PC that orchestrates this, like which PC needs to be spun up, which PC needs to be like brought back down, shut down, or what resources need to be allocated where and stuff like that. And that's literally Type 1 hypervisors. Type 2 hypervisors are more for personal use, right? So they're not really used in large scale. So if you have Windows, right, and you want to like just spin up like your favorite Linux or something, I don't know, yeah, whatever, do whatever you want. You would generally use Type 2 because you just download VirtualBox or something of the sorts, and then just download your ISO file from wherever. So if you want Windows 10 as a virtual machine, you just go to Windows and like download the Windows ISO, and then you just have your virtual machine up and running. So examples are, we have Windows with Hyper-V. It's available if you have like a valid Windows like subscription or like the activation code. We'll look at it later, but that's like it's just there with Windows. It's cool. I like it. It's not bad. Linux has KVM, which is quite beautiful. KVM is like, I love it because it's like it's available with every Linux kernel. So if you have a Linux PC or any Linux, I don't remember, I think it's 2.60 the version number. I'm not sure, but any kernel, Linux kernel above 2.60 or whatever, has this kernel module that can be used to virtualize at a kernel level, which is great. I love it. And then there's a lot of other benefits that I like about Linux KVM, but that's just there. And then you have like hypervisors like from VMware and stuff like that. They're cool too. Type 2 hypervisors are the software based on a software level. You have Microsoft Virtual PC, VirtualBox, and all that stuff. That's just an example. Then now we'll just quickly do a Hyper-V example on this PC. Just look at what it looks like.
Okay, beautiful. So here we are. So quick little cut, but this is the fun bit. So we've studied the theory, we've looked at the theory, no one cares, it's all good. But now, Hyper-V is basically what? A type 1. So we're now... So what you can do with Windows, this is quite nice, I like it, but what you can do is you can enable something called Hyper-V, right, in your Windows machine, and what that does is it implements a hypervisor just above the hardware, just like type 1 hypervisors, and then, technically speaking, if you enable Hyper-V on your machine, what you're basically doing is you're running Windows 10 as a virtual machine, kind of, which is weird, but yeah, that's just how it is. And how you do that is you go to your start machine, you start, like whatever it's called, your options, and then you do turn Windows features on or off, and then you get this bad boy, right? If you look here, you can see your Hyper-V. You just tick that box, and then you restart the machine, and that's it. Then technically speaking, you're running Windows 10 as a virtual machine. And what this also gives you is Hyper-V Manager, right? Which is this what it's called, hypervisor. And what you can do is, so I previously installed Kali Linux, which is just like the penetration testing Linux, because just I like it, and I'm kind of learning like cybersecurity stuff. So what I do is I just click on it, and this is it, right? So it gives you the ability to have a virtual machine running alongside your Windows 10 machine, technically speaking. And this is it. So if I click start right now, do I want to revert? No, I don't want to revert. And like this is it. So it'll start my virtual machine, and I will then be running Linux alongside my Windows 10 machine because of Hyper-V. And if it should load up here, so I'll load it up real quick, and this is it, right? So you're running 2 operating systems as a type with the type 1 hypervisor, and that's just it. So it's not very hard, and you're able to configure this to your heart's content, right? So if I go back to, like, let's say here, so you can look at the settings, right? And I can give this how much of a memory I want. So I've given it like 8,000 megabytes, so 8 gigs of RAM. I can do security stuff, I can give it space, and like literally anything I want, I can do whatever I want. So I can also show you, let's see, hardware, where's the processor? Yeah, there you go. So I have a i7 hexa-core processor, right? So the number of, like, you're able to divide your cores up and then give this machine how many other cores you want to increase or decrease performance based on whatever you want to do. So like, remember this, so I've given it 4 virtual processors, right? And it has 8 gigs of memory. So if I go back to my virtual machine and then just let's do that. Yeah, so this is, so we saw the amount of memory I gave it. So I gave 8 gigs, and then we have four virtual processors, right? And then what compatible it does, sockets 1. I can edit the threads as well, but it doesn't really matter. I'll just show you quickly, right? So let's go back to the virtual machine, and then full screen. Okay, sweet. So this is a virtual machine right now, and if I do new fetch, you can now see. Yes, look. So it looks at my CPU, right, which is an i7 10, whatever this is, but look at the number of cores. This is wrong. It, like, you cannot have this specific Intel core processor with 4 cores because it's not made. But because I'm allocating it a certain number of cores, it thinks that's it, and that's all it gets from like this hardware. So the hypervisor is making sure that it's getting a limited amount of hardware, and that's about it. And also it's using like 8 gigs of memory because it was given 8 gigs of memory. So I have 16 gigs of memory on my computer, but since I'm allocated only 8 gigs to this machine, to this virtual machine, it will only take 8 gigs and it will be contained within that set location of RAM, CPU, storage, and everything. And that's kind of the beauty of it. So if on a personal scale, like, it's like benefits of having virtual machines are like, let's say you like just if you get a, like let's say viruses for example, you get a virus, a ransomware or anything, it's always it's most of the time contained within this specific virtual machine, just because of how it's built, because it doesn't, like, this virtual machine does not know anything else exists on the hardware other than itself, unless it's configured to do so. Now, in terms of viruses, there are VM breaking viruses and stuff like that, but it's highly unlikely that anyone really gets affected by it, right? I mean, it is likely, but it's probably not very likely. So there's just there's just a bit more security and stuff like that associated with all this stuff, associated with virtual machines. But yeah, this is literally it. So you're able to run multiple virtual machines on a single bit of hardware. All the virtual machines will think that their allocated resources are the complete resources of the hardware, but that's not true at all.
Okay, so this is the task manager on my Windows 10 machine, so my native machine, which I normally use. So my Windows 10 machine has access to all the resources, all the physical resources that I have on my computer. So that means the number of cores that you see here, so cores here, is the real maximum number of cores that this computer has to offer physically. So you can see that it's 6, right? As a stark contrast to what we saw before, which was 4. So when we saw the number of, like, when we gave Linux 4 cores, it assumed, or it will always think that this machine as a whole has 4 cores and that's it to offer. So what I'm trying to show is that we can control the amount of resources we give our virtual machines, right? And that's the whole point. So just as we saw with the number of cores, so we can also see with memory. So the Linux machine that I showed previously had 8 gigs of memory because it was given 8 gigs of memory. But physically speaking, this machine in itself has 16 gigs of memory. So we gave half of it to Linux, and it only uses it when that machine runs. When it doesn't run, all that memory is up for us to grab. So that's how it works. So right now you can see 16 gigs in use is like half of it, so like 4.8 or 5 gigs. And yeah, so you understand like the amount of physical resources we have and the amount we are able to give to this virtual machine. And that's the point, right? So when we give that virtual machine like certain amount of CPU or RAM, it will always stay contained within that set amount and cannot exceed it. So that's why you have a certain, like, a huge amount of control within that sphere. And that's the point. That's what I'm trying to, like, just show you real quick. Okay, sweet. So that's basically it for this video. I just wanted to go over the theory of the virtualization, quickly like run over the types of hypervisors, and then just show you an example in Hyper-V. So we've done all of that. Next time I probably will go into a bit more like within the same sphere. So it'll be using the information that we had or gathered today, and then we'll go a bit deeper, and that's how I want to start doing things, just so it starts making like chronological sense. But so yeah, we looked at virtualization today, what virtualization was, types of hypervisors, and then just an example in Hyper-V. Maybe next time I'll set up a machine in Hyper-V and then we'll probably just have a look at that. But that's about it. All good for this video. I hope you enjoyed and stuff. Do the YouTube algorithm stuff if you can, but otherwise enjoy. Laters.